Testing. Testing.
Check, 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 check. 1, 2.
I'm trying to get the slide, and
Yeah.
I walked out of the thing again.
Check, 1, 2.
What is astronomy on tap?
Check, check. Hey, check. Check. Check, 1, 2. Yeah, I think you have to boost this one a little up. Well, with the mask, it's a little hard. Check, 1, 2. 1, 2. Oh, yeah, works better now. Yeah.
Adam, are you ready?
You want to go this way? Maybe?
Okay.
You want to sit here?
Testing. Testing.
Hello. Who is excited that we're back? Hell yeah! Hell yeah! A great event we have prepared.
So we like to start first by asking how many of you have never been to Astronomy on Tap before? All right, a bunch of newbies. All right. How many of you have come more than one time back before 2020 happened to us? Okay. And how many of you have come every month since March of 2020 just wishing that we were here and you sit in this room watching and waiting?
Who has been
One or two, okay.
on the remote Astronomy on Tap we did? All right.
Shout out to Scobie for that, Michelle.
Yes.
Cheers. Woo!
Yeah, congrats, Michelle. Awesome. So yeah, we have a great event tonight prepared for you. But before that, let's introduce the team because people don't know us. So
Start with you. Oh.
starting here, we have Adam Bark. Woo! Tracy Becker.
Vincent Hugh.
Christine Ray. Who also graduated during the pandemic, so big shout out. Awesome. And our newest addition, Michael Velez.
And Lizette helped with some of the trivia, so she's out there in the virtual space. So she's moved on to DC since 2020, since the last time you saw us. So good for her. Good job, Lizette.
And Sam, of course. Sam decided that Austin was more cool than San Antonio, so she moved to Austin.
Don't make people boo Sam.
I'm just kidding. She got an awesome job, so.
All right.
All right, so what is Astronomy on Tap?
Let's see if this works.
Does it work?
All right. So since there were so many of you who were new here, that's very exciting. Welcome. Astronomy on Tap is actually a global event that happens in different cities all over the U.S. and all over the world, where we gather in bars or other venues to talk about really cool stuff in space. How many of you knew that there is space research happening right here in San Antonio? All right, good. Some people didn't. How many of you didn't know, if you want to admit to raising your hand? All right, awesome. Well, there's actually a ton of space scientists here in San Antonio, and both through the Southwest Research Institute, which is where most of us work, and also through the University of Texas San Antonio, which is where two of our speakers are from as well. So yeah, UTSA, go Roadrunners. Woo. But if you happen to be out of town and you want to just watch some really cool space talks, look up what other events might be happening in the city you might be visiting. Oops, I'm going the wrong way with this. Okay, so yeah, so we will be back monthly. So yay! It's going to be the first Wednesday of the month. So we'll see you all back here on June 1st. Yeah. But yeah, it's a great opportunity. We've got cool talks. We've got prizes and trivia at the end. And this week, we're actually going to also be doing a cool Star Wars theme. Anybody know why? All right, I think a few of you knew why. Excellent. Okay, so with that in mind, are you doing the...
So we'll have two talks about, Star Wars theme. There's a lot of news also that's coming up in the astronomy world. So Caleb is going to do astronomy in the news section. And then I'll talk about the events in town that are happening. We have a lunar eclipse coming up soon. And we have some star party coming up soon also in the surrounding area. So let's start with the first speaker.
I would like to invite Obi-Wan Kenobi up to the stage.
What
Are you
microphone
Qui-Gon
would
or are you
prefer?
Obi-Wan?
I'm my own Jedi, thank you very much.
Preston, grad student, Jedi extraordinaire.
This is nice. It'll protect my consonants. Oh boy.
Okay, so this is... are you a Jedi or are you a Okay, Padawans.
In terms of graduate school, yes, I am a Padawan. I have not been granted the rank of master.
Okay, so Michael Preston, Padawan, if everyone's happy with that, is a third-year PhD student at the University of Texas, San Antonio. He works with Dr. Angela Speck, our second speaker. I'm losing my bio here. Studying the formation of dust around dying stars. He is a longtime aviation and spaceflight enthusiast, but has little intention of leaving the atmosphere himself. What kind of Jedi are you?
You know, when they have functioning X-Wings, I'll give it a shot. But spacecraft today are scary.
Fair enough. Until then, he is content to observe the heavens through a telescope. Let's welcome Michael, our first speaker.
One second. As is tradition at Astronomy on Tap San Antonio, I need you to think of one word that you might say fairly often, but not too often in your talk. And every time Michael says that word, everyone here needs to go, woo, and have a sip. So let's have a practice. Word.
The word will be technically.
All right, take it away.
Thank you. Which of these buttons does it? Is it up or down? Okay. Keep going. Keep going. Keep going. I think there's been a disturbance in the force.
No. Yeah, just a little reminder, we're a little bit rusty, so, just take us a little bit of time to get back to the normal track. So if you have any questions during the talk, text this number. Any questions about Star Wars, about, the speaker or anything, just text the question, and there'll be a question and answer at the end of the talk. So.
I have a numbering system. I've forgotten it already. All right. Okay. It's getting a little warm up here. Hello, everyone. Thank you for the person who said that. So yes, my name is Michael Preston. Today I'm going to be talking a little bit about spaceflight in Star Wars, and nary have the words escaped my mouth that I've already sensed some of the thoughts of the audience members. Aha, he's going to talk about why the X-Wings don't need to bank to turn. He's going to talk about how they need external thrusters to push themselves around in any direction that isn't front. And yes, those arguments are technically true. Thank you. It works. But also, I think they're kind of dumb. So today, no, I'm not going to talk about the things that are wrong, necessarily, with the Star Wars conception of spaceflight, but today we're going to talk about the things that are potentially pretty cool and potentially doable. So I've set some requirements for myself. Relevant criteria are going to be, point it this way, right? Relevance to Star Wars should be pretty straightforward. Theoretically / technically possible. Thanks again, we're going to have a couple of those. And the third criteria, it's got to be cool. I think if we make 1 and 2, we'll make number 3, but I'll continue to check in over the course of the talk. So we've got 3 topics to get through. Let's start with the first one. You might recognize this little booty over here as the rear of this. This is the TIE Fighter, the eponymous main fighter craft of the Galactic Empire. It has about 1,000,001 variations, and they're all tied together by this. This is the TIE, the twin ion engines that power the spacecraft. Ion engines in the Star Wars universe are pretty quick. They can keep up with things like X-Wings and Y-Wings and all the other really zoomy spacecraft in Star Wars, but they do have a real-world analog. This is an ion thruster, an electrostatic thruster. It's an electronic propulsion system that was first presented in a paper in 1911 and was put into practice, flown first in 1964, and has been in use at NASA since. That's the first spaceship over there that, is this a laser? Ha ha! We need lightsaber noises. This is the first spacecraft that flew a suborbital flight with an ion engine on it. This is an N-star ion engine that was flown on the Deep Space One spacecraft. It's technically possible and actually works. This is how it works. The ion engine is composed of a magnetic chamber into which a neutral gas like xenon is pumped. The gas is then ionized with a beam of electrons, creating xenon ions, which are attracted by an electronic potential, or an electric potential, at the rear of the engine that accelerates them to great speed out of the spacecraft, creating thrust. The draw of these engines is that they're incredibly efficient. They use electric power rather than like a chemical energy in order to accelerate, and thus they need very little fuel, since most ion-powered spacecraft, most spacecraft, have solar panels to give them energy. Here's a little comparison between a conventional upper stage rocket built to fly in vacuum or close to it and the Deep Space One spacecraft. I've done a little calculation for this spacecraft to accelerate to 4 kilometers per second. It would require 1,300 kilograms of liquid fuel. That's a lot compared to the 75 kilograms that this bad boy uses, which is pretty cool. The only issue is that this rocket kicks out about 900 kilonewtons of thrust, and the ion engine is a little slower. It's like 6 orders of magnitude. Yeah, it's so you're not going to be keeping up with an X-wing in this, but it is a current technology that has a direct analog to Star Wars. So I'll ask again, is it relevant to Star Wars? I think it is. Is it theoretically possible? It is theoretically possible because we actually have the technology and we're using it right now. Is it cool? Anyone who owns an electric car can agree with me. Electric propulsion is really cool. So let's move right along. Got that first one. The second one, you might recognize this as one of the most recognizable spacecraft in all of science fiction. This is the, let me think, Incom T-86 X-Wing Starfighter, which is my favorite, at least from the original trilogy. And it's got these 4 lovely rocket engines that come out of the back of it. Or maybe they're not exactly rocket engines. In fact, if we go back one, which I can, haha, you can actually see it kind of looks like they're jet engines. What's that? It's a spacecraft. They don't need air-breathing engines in space. What the heck is wrong with them? Well, as you can see here in this cutaway book that I stole from my middle school library and never gave back, we can actually see, oh, some of my animations didn't make it in. We can actually see, go back one, this part of the spacecraft's cut away, and we can see the internals of the engine. I'm taking this as canon. I have no idea if it is. And when I was looking at this image, I actually drew some comparisons to this. This is the Sabre hybrid air-breathing rocket engine that has been, at least is currently in testing for a proposed single-stage-to-orbit spaceplane called the Skylon, which is a pretty cool technique, a pretty cool concept aircraft. It uses a air intake here, a pre-cooler in stages of radiators here, an air compressor, ramjet thrusters, and a traditional rocket engine that can use oxygen from the planet's atmosphere in order to create thrust. And then once it gets above the atmosphere, it closes this part and switches to a closed cycle mode that it can burn without needing atmospheric oxygen. And if you look at the X-Wing, my animation was going to make this a little easier to see, but I think you can still see it. I can see maybe some similarities. Look at these like progressively larger stages of ringed radiators. What's this kind of look like, maybe? What's this? This is an air turbo compressor. Well, look at back here. This looks like an impeller and a turbine from the air compressor in a jet engine. And I think that might compress some air. There's an airway, obviously, at the top of this little part of the intake here. So my theory, tenuous as it is, connecting these two is that the X-Wing and other Star Wars spacecraft like it, like the U-Wing, that is made by the same Incon company in the universe, uses a hybrid air-breathing rocket engine just like the Skylon, which I think is pretty cool. Now, technically, we don't have this kind of technology yet. It's still in testing. And part of the reason for that, so here's a comparison of the Skylon itself compared to the X-Wing. It's a little bigger. In fact, the X-Wing's about the size of the engine, so that's one thing. And most of this spacecraft is hydrogen fuel. In fact, all of it is, except for this little center portion, which is the oxygen tank and a payload. And the engines, of course. One of the issues that we would come up with if we wanted to build a modern X-Wing is that we do not have anything that is near energy dense enough to act as fuel for it, and our engines are far too inefficient to get this little thing any higher than the stratosphere, really. Ignoring things like air resistance and aerodynamics, because that's not what they had in mind when they were building the spaceships for Star Wars. But I'll again check back in. Is that relevant to Star Wars? I'd say the X-Wing's pretty relevant to Star Wars. Is it technically possible? It is. In fact, the Sabre engine itself is in testing currently. I think the Skylon's been postponed by the European agency that's been running it, but it's theoretically possible at the very least. Is it pretty cool? I think it's pretty cool. So let's move right along. Got that one. So the last thing I want to talk about today is probably the most, and I can already feel the skepticism, the most ubiquitous plot device in any science fiction show, and that is faster than light travel, unless you're watching The Expanse. Which, of course, I can feel the disturbance in the Force already. Michael, that's impossible. You can't go faster than light. There are laws for this kind of thing. Well, yes, technically. But also, we might be able to finagle our way around it. So in the universe of Star Wars, hyperspace works, essentially, by taking a spacecraft and using the hyperspace drive, which is their specific science fiction MacGuffin, that vaults the spacecraft into a parallel dimension, and in that other dimension, either there is no speed limit, or the speed limit is significantly faster than the speed of light, and you can travel as far as you want, and then come back into the Star Wars universe. That's how I understand it. Now, technically, there are some theories of cosmology, known as brain cosmology, that's without the eye, not the organ, which consider a certain set of dimensions that you can ascribe to our observable universe, and then you can theorize about higher dimensions and higher dimension space, or a hyperspace that exists with probably significantly different physical laws if you were to exist in that higher dimension. Say, if you were a fourth dimensional being, you could move in time the way we move in the 3 dimensions that we do. That's pretty cool, but we still don't really have any technology or really any theories that allow us to interact with any of these higher dimensions or parallel dimensions, so this really seems like kind of a long shot in terms of actually being able to travel to one and use it to our advantage in that way. But we're not out of luck just yet. There are some actual at least one actual theory that I came across that could potentially give us faster than light travel, and that's the warp drive. In specific, a Mexican mathematician named Miguel Alcubierre in 1994 published a paper detailing a metric in which you could potentially warp space and time in a way that would require... Where's my figure? Let me just put everything up here. I want to see this figure. There it is. That could potentially warp space and time in a way that leaves a bubble of flat, quote-unquote, space-time around a spacecraft, contracts space-time in front of it, expands space-time behind it, and then this bubble with the spaceship in the center of it, is pushed like a surfer on a wave through the universe at, theoretically, any speed. Close. Not quite. Now, this obviously is very difficult to do. The first paper that talked about it estimated about 10 to the 63 kilograms of matter converted losslessly into energy would be required to move a ship like this with this kind of drive from one end of the Milky Way to the other. And if you don't know, 10 to the 63 kilograms of matter is more matter than there is in the observable universe. They did some more research, though, and were able to narrow it down to 700 kilograms was the lowest that it could get. It's between that and the mass of Jupiter, which is a lot better. It's a lot, but like compared to the mass of the observable universe, that's great. We still can't do it with modern technology, though. It also requires something called exotic matter, which is what you need for this part. Normal matter already does this kind of thing to normal space-time. It creates a depression, theoretically. If you've ever seen like those orbital mechanics demonstrations where they put a heavy weight in the middle of like a nylon cloth or something, that's what normal matter does. But none of it does this. This is the opposite. So you would need something called exotic matter, which has negative mass and is altogether weird, and I'm not really going to be able to get into it because I'm not qualified, and I'm not sure anybody is, really, based on what I've read. However, technically, this is possible. And you might say that the odds are pretty astronomical that something like this would actually be built in really anybody's lifetime. And I'm sure once we get closer, we'll find more difficulties with it, but I'm going to follow my favorite Space Cowboys example. I'm going to say never tell me the odds, because this is really cool. Let's see if it matches our criteria. It's relevant to Star Wars. I'd say it's relevant to all of science fiction, most of science fiction. Is it technically or theoretically possible? Thank you. It is. Is it cool? I think it's pretty cool despite all of the difficulties. That is all three of our topics covered, and I will take any questions that you have. Thank you very much.
All right. Awesome. Fantastic talk.
Thank
really.
you.
Text your questions, guys. This is a number. Any questions about hyperspace, about Jedi? I got some question about Jedi hair care product.
Oh, yes. So like, at least like 60 hours of meditation a week. Make sure that you, isolate yourself from any dark side sources. Dark side causes frizziness and greasiness, and that's not really what you want. You don't want Kylo Ren's helmet hair. And no parabens or sulfates. Those are bad for you.
So I got a question about hyperspace lanes. How does it work?
Okay, so there's a couple of things. One of the papers that I read about the Alcubierre metric, about the warp drive, talked about something that is at least equivalent to what I've read in science fiction about hyperspace lanes, which is that, in my mind, I keep thinking of like ley lines or like highways that you can go faster than light, but if you try to go outside of them, you're stuck with regular physics. One of the theories about the warp drive is that you're not actually going to be able to go faster than light using it because space and time will exert forces on the bubble and slow it down. But if you did start warping space and time in a hyperspace lane along the path that you want to travel, you could technically, if you want to do it, sure. You could technically have a spacecraft travel along that pre-warped path, so, like creating a slide out of space-time, basically. Outside of that, I don't know too much about hyperspace lanes as they pertain to physics or science fiction.
All right, we're going to go into a very technical question. If you wrap speed through hyperspace, does time change? What's the question? What was the second word? If you wrap speed through hyperspace.
So I know that if there was some way to travel faster than light in real space, then time weirdness gets involved because of relativity. If you are in hyperspace, it really depends on what set of dimensions, because there could be any number of weird dimensions out there like X, Y, Z, time, falafel, like I'm not a mathematician. I don't know all the names, or a cosmologist, but I actually did come across like some articles talking about how the TARDIS works, if you've seen Doctor Who, which, yes, kind of operates on a similar principle. If you're in a different dimension with different laws of physics, maybe you can move around in the fourth dimension there, do a little interstellar type thing. So potentially, you could travel through time, or potentially even change the passage of time, since we can warp space and time in this dimension. If you're in a dimension where like X is T, is corresponding to time, then maybe you could change the flow of time, or at least slow it down.
Yeah, awesome. So we didn't have any questions, and now we have like 20 questions that came, so.
You can also catch me afterwards if we got other stuff to do.
Which is the most egregious, impossible science in Star Wars?
The most egregious, impossible science in Star Wars? Okay, I wasn't going to mention this, because not only does it violate several laws of physics, but it violates the internal logic of the movies itself. Have you all seen the 8th episode of Star Wars, episode 8? So the warp speed collision, or the hyperspeed collision between the Resistance fleet and Emperor Snoke's ship is wholly inconsistent in the canon of Star Wars because, like I mentioned, hyperspace is supposed to vault your ship into an alternative space where real matter has much less of an impact, so it wouldn't have actually collided with it at all. As much as I love that scene for its cinematic effect, and I think it's the one scene in Star Wars where they actually get it right and there's no sound at all. It was really cool in the theaters, but when I went back home to think about it, I thought, okay, well that doesn't make any sense based on how the hyperdrive is supposed to work. And also, if that's how starships went into hyperspeed in the Star Wars universe and experienced some incredible acceleration like that in real space, everyone inside every spaceship that went into hyperspace would be turned into mush, and the spaceships would probably be torn apart by the sheer force of the acceleration. So, I mean, you can hand-wave sci-fi stuff, but if we're going to stick with the Star Wars canon, and as far as I understand the actual physics, then that would probably take the cake from the stuff that I've seen.
That's a great answer.
I said I wasn't going to talk about the sequels, but you got me.
So in that time-space bubble you talked about, would we age as a human?
Okay, so theoretically speaking, since... thank you. Someone really needs those drinks. Let me see if I can actually... Oh, did you append a... That's good. Thank you for appending that. If we created a bubble like this, note how space-time inside of the bubble, in this wonderful artist's rendition, is flat, just like it is outside. Essentially, what we're doing is we're creating our own rest frame. So something akin to like what a frame shift drive does. That's another science thing. We're creating a stationary rest frame and pushing that frame instead of the spaceship. The spaceship isn't traveling, so essentially, according to general relativity, you are not accelerating at all. So you would age as though you were sitting in a rest frame. You would age, theoretically speaking, I think you would age faster than we are aging right now, based on universal time, because we're accelerating, orbiting the sun. But inside this bubble, you are in an entirely isolated frame. So no. I mean, relatively no.
Yeah. All right. Last question that came online from Lizeth, which is, where did you get the costume?
Hi, Lizeth. I got...
Very important question.
This costume is a loaner from our other speaker tonight, Dr. Speck. She purchased this and is being so charitable as to let me use it because I didn't have enough time to make my own space monk outfit.
Awesome. Well, a big round of applause again for Michael Preston. Awesome talk.
Everyone.
Congrats. Yeah. We'll take a 10-minute break. If you have any questions, you can ask him. You can tip your bartender, order more beer, and we'll be back soon. Yep.
Okay, good. All right. Go ahead and. Are we ready? Yeah, we're ready.
All right. How is everybody feeling right now? Yeah? Are you ready for more Astronomy on Tap? So now, let's talk about what's new in the astronomy world. Caleb Guimard will talk to you about what's new and what's up and coming in the sky. So go ahead, Caleb.
Well, good evening, everyone. Nice to be back, isn't it? All right. So I will go ahead and go through some of what is up in the skies and out and about in the universe that is big news right now. So let's go ahead and take it away first and foremost. Forward the slide, please. Press down. Oh, that is the most counterintuitive remote I've ever seen in my life. So, if you guys want to see some really cool things in the sky yourself, no telescope required, you can right now, but you have to wake up early. Get out about 5 in the morning or so, and if you look over toward the eastern half of the sky, you will see a number of planets in a row over the horizon. You will see Saturn, Mars, Jupiter, and Venus, all a nice row in the sky there. You cannot miss them. They will be very, very different from the background stars. The way you can identify planets in the sky is that they are, one, very, very bright, and two, they do not generally twinkle, at least not that much. Now, there may be a little bit of an exception here because some of these are very, very low in the sky, so you get a lot more of that kind of waviness down there toward the lower horizon. There is a meteor shower going on right now, by the way. It is the Eta Aquarids meteor shower. It's not one of the best meteor showers of the year, but hey, peak rate's probably about maybe 50 meteors per hour in a good dark sky. So if you want to go out, find that nice dark sky out there, go out there, and hey, you may be in for a good show. Now, there is something coming up a little later this month that you need to keep in mind. It is a lunar eclipse. And a lunar eclipse, just as a review, many of you probably already know, but I'll go ahead and describe it anyway. The moon passes behind the shadow of the Earth, and because our Earth's atmosphere splits up the sun's light into its separate colors, you actually see a redder region of light toward the center of the shadow. And so in a total lunar eclipse, if everything's set just right, you get this kind of blood red moon appearance. So that will be on May the 15th. Peak of the eclipse is at 11 o'clock p.m. local time. You can't miss it. Hopefully the weather cooperates. It'll be nice and clear outside, and you'll be able to see that eclipse. Now, the biggest news for many of us in the room is the fact, of course, that the planetary decadal was just announced. Yeah, all right. And many very interesting missions for the coming decade were announced during this particular decadal. First and foremost, a couple of the quote-unquote flagship class missions, the biggest and most expensive of the missions. A Uranus orbiter and probe was prepared. Yes, I know, very, very funny. And then going to a less embarrassing planet, go to Saturn, and it is a moon, yes, of Saturn, Enceladus. There was a Enceladus, yeah, all right, yeah. An Enceladus orbilander was proposed. A next major priority outlined was a Mars sample return mission. Some of this is already going on in the sense that the Perseverance rover on Mars is collecting samples for this potential sample return mission. Then there are a number of other things, various proposals for lunar missions, a near-Earth object surveyor, all sorts of really great science coming up in the next decade, pending, of course, that the funding is made available, and I think we have a great future in store for us. Now, speaking of Perseverance, Perseverance at Mars has actually been a very interesting mission recently in the news. One, there actually has been this imagery sent back of I guess you could call a Martian annular solar eclipse where the moon Phobos crossed in front of the sun in such a way that the Perseverance imager could actually see that taking place. Really cool imagery. Now, Perseverance does have a small helicopter that was taken on board it called Ingenuity, and that particular helicopter actually recently sent back some imagery of the descent equipment, including the parachute and the broken up parts of the aeroshell for Perseverance. So really kind of neat imagery there from that mission. It's actually just over a year active now on the surface of Mars. In human spaceflight news, a lot of activity on the space station right now. In fact, this is a slide that includes an image just from today where command of the space station has been handed over basically to a part of a newer crew. All right. So there are actually right now 11 spacefarers on board the space station. That's a lot of people. 4 of those will be coming home here very soon. The crew of the Crew 3 mission will be coming home toward the end of this week. That is actually going to be late Thursday when that crew comes home. Toward the end of last week, that was about mid last week, early last Wednesday, the crew of Crew 4 launched on a SpaceX rocket. So that has been NASA's 5th crewed mission using SpaceX's rockets, and that has been the 7th crewed mission for SpaceX overall in the past 2-year time span almost. A really, really successful program, and they are within a busy launch schedule. So this image here actually does not show their launch. This is one of the Starlink satellite launches on a very similar rocket. Here's the Crew 4's rocket right there, and then there is the Space Launch System booster for the Artemis 1 mission, which should be coming up here later this summer. Yes, so a lot of activity going on in the crew launching. Now, in other news, a company called Rocket Lab, a little on the loud side, a company called Rocket Lab, just the beginning of this week, Monday, launched one of their own commercial rocket launchers, launched 34 satellites. But what was really cool about this rocket launch was the fact that it will actually, there was actually an attempt made to recover the first stage of this rocket via helicopter. And they did actually capture it with the helicopter. Now, they didn't do everything they wanted to do. It was just a test version of this. But it certainly did prove the ability to recover rocket stages for further reuse using this helicopter capture method. So if you watch in this video, eventually you'll get the helicopter view of this. So there's helicopter view. And it's eventually going to capture the parachute that first stage is on. You can see a first stage there. And there we go. It just nets it right there. Yep. Yeah, so that was really a very interesting thing to watch earlier in the week. Now, here's probably some of the biggest news. Yeah, all right. The Webb telescope, JWST, is proceeding extremely well. The optics are, for the most part, aligned, so many of us have already seen this image. This was a test image for the initial mirror alignment, and what's really cool about this picture are all of these galaxies that you can see in the back. Just really, really awesome imagery there. There's a alignment selfie for the actual mirrors themselves. You can do this clever thing with near camera. It can put it in a odd focus so you can actually see the background mirrors. But this is the most interesting image that's been released so far. This is from each of the sensors themselves. They're on board this telescope. Yep, right there. And the most interesting thing about mirrors, of course, that's cooled down to 6 Kelvin, 6 degrees Celsius above absolute zero. They're down to that temperature, and it's operating beautifully. So hopefully by midsummer, we get some really great actual full operational imagery from the Webb telescope. That almost wraps up what I have for you. Just a few things to keep in mind. One, this Friday at the UTSA Observatory. Go there, go to the campus, find the Flound Science Building. We are doing observing at the UTSA Observatory this Friday at 8 o'clock p.m. You do not want to miss that. Tentatively, there will be a number of us that do the observing for the Kurzweil Junior Observatory out at South Llano River State Park on May the 8th that evening. Beautiful place to observe the skies. It is really fantastic. If you get the chance to make a nice trip up that direction, please do indeed do so. And don't forget, we have a solar eclipse series coming up, 2023 and 2024. I will continue to remind you of this in every single one of these Astro News segments for the next series of Astronomy on Taps. So thank you very much, and enjoy the rest of the evening.
Awesome. Thank you, Caleb. That's awesome. Thanks so much. And you forgot to mention that the May 28th is actually the new moon, so it's going to be an awesome time to observe the stars. A little more on the lunar eclipse coming. The Scobie Center is actually organizing a watch party on May 15th, so it's a Sunday. And as Caleb said, the totality will be around 11 p.m., so it's kind of doable, you know, if you want to just hang out on a Sunday evening and catch this eclipse. So the Scobie Center is in San Antonio, downtown, close to the San Antonio College. And if I switch here to the eclipse map, you can see that the eclipse starts around 9 p.m. It is full around 10:30, maximum at 11. And then it kind of ends around 1 a.m. So you can catch the beginning of the eclipse, and yeah. We will have our telescope out there supporting that. Awesome. Yeah, and Tracy and I will also be there to like support the party on May 15th. So, Scobie, yeah, awesome. Big round of applause for the Scobie.
Pray for clear weather.
Something I'm even more excited about is the first annual new moon in West Texas, in Marathon, Texas, on May 28th. It's a fantastic place where there's like pads for astrophotographers. There is a visual observatory, so you can like put your eyes on a pretty large telescope. You have like also, if you want to store your telescope over there, they have like a remote access to hangars. So you can put your telescope and operate it remotely. And it's a beautiful place. As you can see, you know, the weather is always amazing there. It's fantastic. Just to give you an idea of how good this place is in Marathon, this is the map of the light pollution in the US. So you can see like let's boo the East Coast, you know. And if we zoom around Marathon, all right, let's move on. All right, so Marathon is actually right around here. So Marathon is right here. It's an awesome place. It's a small village where they fight for light pollution. So they really like minimize the amount of light pollution. And it's almost as good as McDonald Observatory, which is located around here. It's slightly higher elevation, but Marathon is an awesome place. And just to give you an idea, this picture was taken from one of the telescopes over there that made the astronomical picture of the day on January 11th. A zoom over the Orion belt with the three stars of the Orion belt, the Horsehead Nebula, the Flame Nebula over here. So it's a great place to observe. All right, next I'm going to call Michael to introduce the next speaker while we switch the slides. You good? All right. All right. Here we go, Michael.
Hello, everyone. Good evening. I hope you're all having fun. Oh, there's music.
That's good. And to switch the slide is actually down.
Well, going with the music, I don't know where it's coming from. I'm very confused. I will introduce Dr. Angela Speck, Named after the iconic Angela Davis, she likes bright colors, is a nerd at heart, and has wanted to be an astronaut since she was 5 years old. Originally from Yorkshire, England, she went to college in London, where she was able to pursue her childhood dreams by majoring in astrophysics. After a brief stint as an R&D technician in a Lancashire company run by crazy New Age hippies, she returned to London and completed a PhD in astronomy. After 17 years as a professor at Mizzou, she is now the chair of the Department of Physics and Astronomy right here at UTSA. And she continues to research and teach astrophysics and to share her passion for all things extraterrestrial. She occasionally misses her home in the UK when she gets cravings for good curry and unadulterated Wensleydale cheese. Dr. Angela Speck.
Thank you. Okay. There were slides.
Oh.
They vanished. All right. While we're waiting for them to come back. So, hello everybody. I'm going to talk to you about the destruction of a planet. One of the most iconic and cataclysmic things that happens in any of the Star Wars movies or series or anything is in fact the destruction. Oh, I forgot something. I was supposed to give you a word, wasn't I? Sorry. I need a reminder about these things. Okay. At the risk of having you all leave slightly wobbly, it's going to be the word energy. Okay. All right. So, basically, we're going to talk about the destruction of Alderaan. And, as I said, one of the most iconic scenes and one of the most important scenes across the whole of the Star Wars epic is the destruction of Alderaan very early in the very first movie to have been released. Strangely, Episode 4 was the first one to be released, but there you go. And here we can see the Death Star moving towards Alderaan as it's about to be blown up. And then, ooh, which one is the laser pointer? Ooh, there we go. And then this is the view from the Death Star as Grand Moff Tarkin is threatening Princess Leia in order to get information about the rebel base, and he's going to blow up Alderaan. But what we're going to talk about today is how do we actually destroy an entire planet? Because obviously that's something that we should be thinking about. So here I have a nice visual rendition of this. Now, how many of you remember seeing Star Wars the very first time back in the 70s? Okay, how many of you saw it prior to 1997? Okay, it didn't look like that. I'm a physicist, right? There is this blast that comes in from up here, and then mysteriously, the thing doesn't blow up in all directions or in some reaction to the direction from the blast. There is this extra stuff that comes out of the equator. I have no idea why. I don't think anybody does. So, that is bizarre. Okay, so I thought I'd treat you to what it's supposed to look like. I knew I'd have some purists in the audience. Okay, so, but actually the real reason I wanted to make sure you saw this is that, we see the laser blast come in, and it hits the planet, and it delivers enough energy to obliterate the planet, and it does it in 3 seconds flat. From the blast hitting the planet to the thing exploding, 3 seconds, okay? That's going to be important because we have to deliver a lot of energy in a very small amount of time. Okay, so first of all, we're going to have to talk about, well, how much energy does it take? I did warn you it was going to be bad. Well, first of all, we have to think about how does a planet get held together? And then we need to think about, well, what is the nature of Alderaan? So how do you hold a planet together? Well, basically, a planet is held together by gravity. Yeah, there are a few other bits and pieces holding it together, but the major thing, the major force that holds a planet together, or a star, or an asteroid, or anything else that's that big, is gravity. And we understand gravity well enough that we can basically say this is the amount of, wait for it, energy needed, needed in order to break it apart. That is called the binding energy. And so, yes, it's going to happen a lot. So, in order to calculate that quantity of stuff that is needed to make it explode, sorry, I don't want you all falling over before I get to the end. Let's talk about Alderaan. What is Alderaan like? Well, according to the Star Wars lore and canon, it's actually very, very Earth-like. It's a little greener than Earth, seems to have less deserts, but otherwise, you can see here, it's about the same size, within 100 miles in terms of the diameter. And so I think assuming an Earth-like planet is pretty good. And that's what we really need to do. In order to figure out how much energy we need to deliver, we're going to use the Earth as an analog to Alderaan. Okay, so first of all, we're going to assume that the planet is spherical. It is a perfect sphere. It's not, the Earth is not, but it's close enough, and it's not going to make that much difference. So there's this lovely equation over here. Don't worry about it too much. That is basically the binding of the planet. I'm going to avoid saying it now. And it's this 3gm squared over 5r. Basically, the g is just the gravitational constant. That's just a number. The m is the mass of the planet, and the r is the radius. This works for stars, this works for asteroids, this works for anything that is spherical, okay? And if we put in the numbers for the Earth, that is the mass of the Earth and the radius of the Earth, what we get is that the energy needed to break it apart, to overcome gravity, is 2.25 times 10 to the 32 joules. For those of you that are not so familiar with powers of 10, that is 225 with 30 zeros after it. It's a really big number. Now, I want to give you, it's such a big number, it's hard to kind of conceive of what does that really mean? Now, humans at this moment use power, use energy at the rate of about 18 terajoules per second, okay? What that means is that in order for, at the current rate of consumption, in order for humans to use up enough energy to be equivalent to what is needed to destroy the Earth, it would take 400 billion years. That is how much it is. I want to give you another comparison, because this is going to be important for understanding whether the Death Star can really do it. So, how much of, that stuff comes out of the sun? The sun produces energy, actually, according to probably the most famous equation ever. Everybody has heard of E equals mc squared, but all it really means is that I can take mass and I can turn it into that stuff that powers things, and I just multiply it by the speed of light squared. That's all it says. And this is what the sun is doing every second. In fact, it is converting 400 trillion tons of matter into energy every single second, okay? And so what does that mean for how much power it's actually putting out? It puts out 3.8 times 10 to the 26 joules. That is 38 with 25 zeros after it. It's still a really big number, but quite a lot smaller than what we need to destroy a planet like Alderaan. So our planet destruction needs 2.25 times 10 to the 32. And so basically, if we think about that, the sun is putting out the first number, the 3.8 times 10 to the 26, every second. So if we add it all up, that's how much energy the sun puts out in about a week, okay? And that's output into all directions. That's not how much hits the Earth, that's the output from the sun in all directions, okay? So that's a lot. That's a lot of energy that we have to get. Sorry. Okay, plus, we don't have a week to do it in. We have to do it in just 3 seconds, okay? Now, just to kind of give you a feel for, the sun is actually a very, very average star. The brightest star that we know of is the so-called pistol star. It is 10 million times brighter than the sun. And that means that in terms of the energy it's putting out every second, it is more than enough to destroy a planet. Okay? So it's not a completely unfeasible thing. This is going to be important as we get into how the Death Star works. Okay, so in the Death Star has what's called a super laser, because, you know, that's a really original name for the blasty thing. The Death Star is also powered by a hypermatter reactor. It's not explained exactly how this works, but the hypermatter reactor apparently has the power of that's equivalent to several main sequence stars. Now, for those of you that aren't nerdy astronomers, not all stars are like the sun, and in fact, this graph that I've got here, this is a Hertzsprung-Russell diagram. There will not be a test. You do not need to remember that. And it's just a graph where this is temperature on the horizontal and brightness on the vertical. And here I've got the sun, and it's pretty average. Main sequence stars are any of the stars on here. So they go from things that are 1,000,000 times brighter than the sun down to about 1,000th of the brightness of the sun. Okay? You can also see there are other stars, like Betelgeuse is one you've probably heard of, which is also very bright. It's not a main sequence star. It's a supergiant. And then we have these really little faint stars. Okay, the point is that according to Star Wars lore, the power source, the hypermatter reactor, has the equivalent of several main sequence stars. Well, if it's several suns, that's still not enough to destroy a planet. But if it's several of these blue things up here, you've got plenty of energy. So it's not completely silly that the Death Star has the required power to destroy a planet. There are some problems. Okay, so what are the problems? Well, first of all, you know, I have this laser here, and as the laser light passes through the air, it's going to heat up the air. Now, this little laser here isn't going to cause much problem, but that laser right there, that is going to heat up everything to the point that it's going to melt the equipment around it. And oh my, what's going on with these guys right here? I mean, you know, they are not in any way protected. So, you know, there's a real problem with what's going to happen as you fire up this laser to send out this blast and destroy a planet, okay? So the way that it does it, it's the energy is channeled through what are called kyber crystals. These are the same things that make lightsabers work. But they've got really big ones. I'm not entirely sure where they found them. And that's what's used to do this. But it also presents another problem that when you blast this thing out, I don't know if any of you have ever shot a gun, or even sometimes, I know it's Texas, most of you will have. But, you know, when you shoot something in one direction, there's a recoil, right? And that can happen with all sorts of things that you try to send off in projection. In fact, that's the way jet engines work. Now, the problem is that with the amount of energy that is being sent out per second by the laser, the Death Star should recoil. And it should recoil at 70 kilometers per second. Now, the Death Star is only about 120 kilometers across. So think about the scene. Do you notice that the Death Star moved? No. No, it didn't move. So there's definitely a problem with the physics of how the Death Star is doing things. But there is another way to do this. There is a way to make it more efficient than using a laser. It's not what they do. I guess it wouldn't be as pretty. But there is another way, and I'm going to talk about that just briefly because it's fun. So you can use antimatter. Now remember, I talked about E equals mc squared. E equals mc squared basically means that if you can directly convert mass into energy, you can get a lot of power out. It is incredibly powerful stuff. And if you have antimatter, it will obliterate the matter it comes into contact with. So if there was an antimatter Angela in the room and it came over here, there would suddenly be a very large explosion as me and the anti-Angela annihilated each other and became pure energy, okay? That's going to happen with whatever antimatter you're using. So, assuming that you can get some antimatter, all you need to do is then figure out, well, I need to have the, the 2.25 times 10 to 32 joules, but to get that, I only need 2.5 trillion tons, which sounds like a lot. But it's not compared to, say, a small asteroid. So what this graph is showing you is actually a whole bunch of asteroids. And what I've got here is, if I want to get the right mass, so here I've got the mass on here, we're talking about asteroids that are around this sort of size here. Most of the asteroids are actually up here. You can see there's a bunch of asteroids down here, and these are the ones that fall into this size range. That means that they're of the order of 50 to 100 kilometers across. So something about the same size, an asteroid about the same size as the Death Star, could contain enough antimatter to be able to give you the destruction you need. So all you need is this thing that is the size of a small asteroid. As it hits the planet, it won't just make a crater that destroys the dinosaurs. It will start to react with the matter and cause pure energy, and it will generate, I'd forgotten, damn. And so you can actually cause that the destruction to be done much more easily. But that means you need to throw big rocks at it. Also, it's not necessarily a rock. Actually, the best way to produce, and we do actually produce antimatter. We can produce antimatter. We do it in things like the Large Hadron Collider. If you've got a high energy collider, you can do this. Now, if you can start to make something that is anti-hydrogen, you can then and squish it down really small. You can actually get it to a very dense state, which means you may have something that you can maintain and possibly even shield. The problem with antimatter is, as soon as it comes into contact with matter, it's going to cause an explosion. So how do you keep it so that the Death Star is safe while it's hauling this stuff around? I saw that there are at least a couple of people in Starfleet outfits, so think red matter, okay? Because I am an equal opportunity nerd. Okay, so I just want to give you an idea about this. So this is actually showing you a real asteroid called Ida. Ida is actually kind of a long asteroid. So this is Earth, and this is Ida here, and this is seeing it on the long length. The length of it is about, and its long direction is about 60 kilometers. And the circle there, that's the size of the Death Star. So I just wanted to give you a feel for this. But Ida has much more mass than we need. We actually only need about a tenth of the mass that's in Ida in antimatter form. So again, just trying to give you the idea that we can probably make this work if we, in terms of sizes, containing antimatter. That's a whole other thing. Okay, so I want to leave you with the whole effect with the original explosion, obviously, and the guys in the laser chamber not dying. And I'm going to stop talking and let you ask me questions. Thank you.
Awesome. Awesome talk. Make some notes for Dr. Speck. Awesome. Questions? Guys, you can text here your questions. And before you text your questions, before I get your questions, we're going to have like a big costume contest at the end. So everybody that are costume, come here at the end, and there'll be prizes for the best costumes. All right, I have a question. So could we see dust from a destroyed planet? Could we see like a major dip in the brightness of the star coming from a destroyed planet like you just talked about?
Okay, so that really depends on if the planet is destroyed, how fast it disperses and over what area. So if we think about things like exoplanets and how we detect them, you're looking at a little dip, and you're not actually changing that much in terms of the total amount of stuff available. But dust is more effective. Think like fog versus rain. So it would really depend on how close to its star it is, but it's possible. And it would depend on what the dust was made of too.
Cool. Do you think the Death Star had a recoil laser to like counter effect on the back? You know, just to like.
Oh, I like that idea.
Compensate.
So you shoot in both directions at once just to make sure.
Yeah, and you shoot one on the back so that you don't recoil too much. You know?
That yeah, I like that.
But those guys better have like protection glasses, I guess. What planet in our solar system is the easiest to blow up? Gas giant? Are they easier than solid planets?
Oh, so no, actually, again, the problem is that whatever you're looking at, whether it's an asteroid or a comet or a planet or a star, the main thing that's holding them together is gravity. So you have to overcome gravity. So the more mass it has, the harder it is to destroy. So because Jupiter is much more massive, it is going to take more energy to destroy it.
More energy, you heard it, yeah. Is Starkiller Base from episode 7 more feasible than the Death Star or no?
Okay. Feasibility in Star Wars. So I think the biggest issue I have with Starkiller Base, and don't get me wrong, I actually enjoyed the sequels. Apparently I'm wrong because I have teenagers and they tell me this, but I enjoyed the sequels. But the biggest problem with Starkiller Base is not so much the lasing, although it sucks in the energy from it's taking the power of a single star and then projecting it out to 6 different planets when the original Death Star needs to have, you know, a few 100,000 times a single star or something like that. So it doesn't seem feasible to me.
All right. Any more questions? I guess there's one. Do you think the guys in the laser chamber reported to the Death Star OSHA? I don't know. I'm not sure what it is, but.
As long as Darth Vader wasn't on board at the time.
Yeah. He would choke them to death.
Exactly.
All right. I think if you have any more questions, we're going to take a short break. You can catch up with Angela Speck. Again, thank you so much for this talk. That was fantastic. Thank you so much. Again. And I think she did a talk right before we went to the pandemic about the eclipse. So I guess you did 2 in-person back-to-back. So again, thank you. We're going to go to trivia. We're going to do a 5-minute break. We can play trivia after. There's like a bunch of questions with prizes at the end. There's a costume contest at the end. And if you want to buy any of the swags we have beer glasses, bottle openers, some cool posters. So come check it out.
Yep. And before some of you might be on your way out, I just want to say thank you again, everyone who gave the talks. They were fantastic.
Yeah, thank you so much for the speakers.
Okay, we'll see everyone in 5 minutes for trivia.
All right, if you want to play trivia, we have trivia sheets here. So, yep.
If anybody needs sheets, raise your hand. I gave one out. Okay.
The rules I shall
Friendly.
remind.
Oh, you got it?
The cell phone are not allowed for the trivia, of course. Otherwise, it's too easy.
If you are a student in physics of any sort, you can participate, but you are not eligible to win. Or astronomy, although in our department it's the same, so, you know. You're supposed to work together. stuff, I think. Like this is moon stuff? Or that might be like an asteroid. I don't know. Those might be. Yeah. I think so. Everybody else? Is everybody good with trivia sheets? Everybody got their sheets? All right.
We have some markers left over too.
Yeah, go. For the virtuals at home. Let me check the feed. Can you see Grover? Huh? All right. let's get seated. Let's start trivia. So you said this one is forward.
Yep, that one's.
It is weird. It is weird. All right, everyone. Yes. All right. Who's ready for trivia? Yeah, all right. Yes, I will remind you all because, you know, huh? If you want. I don't care. It's
Hello? Does
if
that
you
work?
because if you use cell phones, right? You would all get the answers right, and these prizes, nobody would win a prize if you all tied, right? So, huh?
Am I blocking the screen?
I don't think
Am I good here?
so. And then for you, let me speak to the virtuals at home. You can participate too. Sorry about the prizes, but you are blessed with the presence of baby Grogu here. So you get something. All right. So, but may the force be with you.
I'm
Let
gonna
us.
go out here so I can
Okay.
leave the screen without being-
Question 1. Which moon in our solar system has a striking resemblance to the Death Star? That's a real moon that is not photoshopped. It looks like that. That is real. Your choices are A, Enceladus, B, Triton, C, Mimas, D, Miranda, or E, Sharon.
We'll just take turns reading questions.
Whoever is in charge of the computer, you're on low battery.
Oh no. Who is in charge of the computer? Tracy? Princess Leia? Oh, good. I was.
Right? Let's move on. Question 2.
Okay. Han Solo incorrectly claimed to have completed the Kessel Run in less than 12 parsecs, as this is a unit of length and not time. 1 parsec is equivalent to. Did you read it? Okay, yes. A. 2 times 10 to the 13 miles. B. 3 times 10 to the 16 miles. C. 1 times 10 to the 17 miles. Or D. 1 times 10 to the 13 miles.
This one is a thinker.
Who just knows this? Who isn't an astronomer? I don't know this. They're all large numbers.
The issue is miles, not like.
Yeah. Oh, are they plugging the computer in?
The problem is there's no close outlets over there.
Oh, that's problematic.
All right. I think I'll move on.
Okay.
All right.
We do have the clicker. We do have the clicker. Okay.
Question 3. This one, we are all talked about it during, or Dr. Speck talked about it. So if you weren't paying attention, that's on you. Which planet was destroyed in Star Wars A New Hope? Right there. You can't miss it. A, Tatooine. B, Alderaan. C, Mustafar. Or D, Naboo. I'm not going to spend a lot of time on this one because if you know it, you know it. If you don't, yeah.
Is Naboo where Jar Jar Binks was from?
Yes,
That's unfortunate.
it is.
Maybe
But
it
it's
should have
also
been
where
destroyed.
Queen Amidala, Padme.
That's
so.
fair. We can keep her.
Yeah.
Question 4. I love this because I'm a big Pedro Pascal fan. What is the name of the Mandalorian ship? Is it A, Fire Spray Gunship, B, Soulless One, C, Ghost, D, Hand of Justice, or E, Razor Crest?
Baby Grogu will be very disappointed if you get this wrong.
Yeah. I'm glad you included a Mando question, though. That made me very happy.
All right, question 5. Tatooine is a planet that orbits a binary star system, the famous sunset scenes in the original movie. Which of these is a real binary star system in the Milky Way galaxy? A, Sirius, B, Regulus, C, Vega, or D, Betelgeuse?
I like this question. We're in the front. Wait, what's that?
Is the one that's most Star Wars.
That's fine. That's relevant, at least. I think you had a healthy mix anyway. Okay, is this the last question? There's a bonus. Okay, last official question. Who created the plans for the Death Star? I don't know how to say these names.
DeRozan.
Oh, A. DeRozans. B. Toydarians. C. The Hutts. D. Geonosians. Or E. Dr. Ray. Don't worry about who that is in real life.
See, we saw these are blurry because they're classified, you know. But we saw the X-Wing plans. Those are the Death Star plans, so, you know. Somebody went all out. All right. That is all the questions, but as always, we've got a bonus. The bonus question today, name the months and days in which each of the 3 original Star Wars movies were released in order. And, of course, the famous poster of the original one. This one is a tough one, but I should know you will get partial credit if you just put the month down, if you can postulate the month. So give it a go. You got 1 in 12. All right. All right. Yes, when you're done, please bring up your sheets to the front, one person per sheet. We're going to use something to mark these with.
Put it somewhere in the middle. I love the team.
Is that everybody? Oh, no, we still got more. Listen, I just want to congratulate many of you on your team names. These are very creative. If I could give prizes just for the names, I would, but, you know. Also, if you borrowed a pen or marker from us, please give that back. We would appreciate it. Could you get somebody to help as I go through the answers? Or is there somebody that can help you? Or? I don't remember how we did it in the past. All right, double checking all the answers are in. All right, last call. Okay, we're going to take a little break to grade your answers, and then we'll present the answers to all of you and the results. So.
Hey y'all, while we wait for the trivia scores to be calculated, we have a quick announcement from our fellow, what's your name? Lee from the DoD.
Hey, y'all. So I'm with the Department of Defense at Brooke Army Medical Center. We are developing exoskeletons for people to walk off the battlefield, and we're having a really hard time finding mechanical engineers. So if anyone is an ME that wants to design really cool exoskeletons to unfold out of someone's back and give someone moving again after they've had pretty sustained severe extremity trauma, please come see me, because there's several job openings. That's my name. Do you know what carbon fiber is? Know how to model human tissue? That is good enough for me. Fair enough. Thank y'all.
Hello? Hello? Oh, okay, good. Hello. All right, first I'm going to go through the answers. So if I could have everybody's attention, please. Thank you. Thank you. Thank you. Very good. Nothing gets a crowd quieter than clapping. Number one, which was our question about the moon that looked like the Death Star, the answer was Mimas. Mimas is a moon of Saturn, for your information. So you learned something new. Question 2 about our parsecs. The answer was A, 2 times 10 to the 13 miles. Question 3 was B, Alderon. If you got this wrong, you weren't paying attention to Dr. Speck. How dare you? Number 4, our question about the Mandalorian. So baby Grogu, the E Razor Crest. Here's the ship right there. It's a very pretty ship. Not really, it's a junk, but The shift knob is what's more important. All right, the binary star in our Milky Way is Sirius, which is very bright star. You can see it even in a light polluted sky very often. And yes, it is in the Canis Major, right? Major? I know it's Sirius, a dog, is because it's in the Canis constellation. Major, right? You'll know. Canis Major, okay. Okay. So, yes. All right, and then the last question, which was a very Star Wars-y question about who made the plans for the Death Star. It was the Geonosians. They also made the very famous and very classic battle droids. Roger, roger. All right, the bonus. They all came out in May 21st and 25th. So, and then fun fact, this was only the first 3. All of the first 6, all of the original 6 came out in May. Solo came out in May, and then later this month, on May 27th, the Obi-Wan Kenobi show comes out. So May is the Star Wars month. There's no denying it. The other movies came out in December, but I think that's just because they wanted to go mainstream Christmas, you know. We all know where it's at, though. It's May. All right. So, now prize time. In first place, so we had these top 3 teams were the top 3 teams. So you all did very well. The number 1 team winning our prize, let's show off the exoplanet poster. Very, very nice poster and mug and stickers and keychain. Team Trigon Gin. Woo! Come get your prize. Picture. Woo! All right. Our second place team winning a poster, a LRO poster. LRO still in operation above our very own moon. So, oh yes, and also a mug, keychain, or not keychain, I'm sorry, and stickers. The Mandy Lorians. Woo! All right. And last but not least, the third place team, which does get a keychain and cool stickers. Team Scobie.
Woo!
Very good. Congratulations. All right.
Our next last event for this evening is going to be the costume contest. So anyone who wants to enter in the costume contest, come on up to the front. This is going to be a decision by the crowd, so everyone needs to be paying attention. Whatever you want it to be. Just a glass or something is good. Yeah. Whatever you make it. You don't win. We lost what?
Is that Speck's husband?
I think so. Oh, that's quite good. Uh-oh. Okay. Oh, man. We got some legit competition up here. All right. Oh, my goodness. Okay. Okay. With one caveat that some of the multiple of these costumes came from one person, so we'll see how that goes. But all right, first up, can you tell us your actual name and also your displayed name?
I'm Vincent Wren.
All right. Vincent Wren, let's hear a round of applause. Okay.
Michael Preston, as myself, because I could be a Jedi, why not? I do have to give credit for the costume to Dr. Speck, but I did make this, so that's something.
Pippa, you're going to be our judge on how the clapping is. Congrats.
I'm Michelle Rissi. I'm the planetarium coordinator for the Scobie Education Center, and I decided to dress up as Princess Leia.
I'm Lieutenant Kara Holcomb with my communications officer, Lieutenant Commander Krista Holcomb, USS Bear, nonprofit Star Trek charity.
Hi, I'm Alan Whittington. I'm a professor of geology at UTSA. I think I'm an Ewok. No, I'm not. I'm Boba Fett.
My name's Spencer, and I'm General Grievous.
My name is Xander, and I'm just a generic Sith Lord.
All right. Okay. Pippa, were you able to discern, or should we have like 3 or 4 step into the front? Come on forward. All right, clapping for the winner here. First to Princess Leia. And then for General Grievous. I think General Grievous gets multiple things that he cannot use yet, a beer glass and a keychain. All right. What's that? No. Okay, I think that wraps up Astronomy on Tap for the evening. So thank you all so much for coming. Please make sure that you have paid and tipped the waitresses and waiters and service people that worked really hard tonight. Any last words, Vin?
Thanks for coming, and stay tuned. We'll be there next month. May the 4th be with you all.
Oh, yeah. And come get some swag up front if you want.
Oh yeah, if you want to buy any